So what's the problem with SOHCAHTOA? What's the problem? Why can't we use SOHCAHTOA all the time? Well, one of the reasons why is because SOHCAHTOA, of course, has its limitation. It has to be a right angle triangle. And if it's not a right angle triangle, then you're looking at a triangle, and here's an example. You'd have to break this guy down, make this right, find this guy, add them together. Boy, that's too complicated. No. There's got to be an easier way. In fact, there is. It's called the sine law. Now, check this out. This triangle has no right angles, but we're going to use a sine law on it. Huh. Well, does that mean if it has no right angles, that must mean it has no hypotenuse? Well, you're right. Okay, so how do I do this? Well, do you remember when we did sine law or just regular sine? I said put eyeballs on it, and then we'd say, okay, that's got to be the opposite. Same kind of idea. Watch this. If you label this as angle A, you put eyeballs on this. It stares across at side A. Those two are actually related. How are they related? This is an angle. So take the sine of the angle and relate it to its side. Okay, so what does that mean? Well, if this is B up here, there's the angle, boom, boom. That must make this little b, and sure enough, the sine of B goes with little b. Sine of B goes with little b. There you go. And then over here, this would have to be C. So the sine of C goes with little c. Sure enough, the sine of C, which is the angle, goes with little c. And that's the ratio that it works with. And you know, the cool thing about this is it doesn't matter which way you write it. You can actually write this as the side over the sine of the angle, or you can write it as the sine, which is the sine of the angle, over the side. It doesn't matter. As long as you're consistent all the way through and you use that, which is the angle over the side, or in this case, you use the side over the angle, as long as you're consistent, it always works. So make sure you always match the angle with its opposite. If you do that, you can do no wrong. Let's look at an example. Oh my goodness, here we go. Now, this is an exact question which does not have this 90-degree in it. So it tells you right away you have to use the sine law. Well, start matching things. Look, ta-da, put eyeballs on it. Boom, it's over here. That must mean those two go together, which means this guy and this guy go together. How does it work? Simple. Let's do the first one. Let's do this one. That's an angle. So here we go. Sine of 45 has to go with the value of x. And since you're dealing with just two of them, you're not dealing with three sides, you're not dealing with three angles, you're just dealing with two sides and one of the angles. Fine, there's 39. Now remember, if sine's on top, keep it on top. Sine of 39 now goes with, look at that, 35. Sweet, excellent. How do I solve this? Real simple, cross multiply, baby. Look at that. So you got 35 times the sine of 45, okay? And you're going to divide by the number that remains, sine of 39. And guess what? That would be your value of x. Well, how do I do that in your calculator? Well, let's see. 35 times sine of 45. I'm just going to bring up my calculator. 35 times the sine of 45. Got it. Enter. Gives you that ugly number. Now, look what's left. You've just figured out this top part. You got to divide by sine of 39. Okay. Divide by sine of 39. Well, there you go. This is 39.2 or 0.326. 39.3, depending on how they want you to answer the question. This one says nearest tenth. So nearest tenth would be 39.3. That is your answer right there. 39.3. Check the units. It's in centimeters. There you go. I can confidently say that that length of that side is 39.3 centimeters. Easy peasy.